let's say I wanted to find the mean and standard deviation of this data right here. And based off of what we've done so far, we would add up all of this data and then divide by the number of data that there is, which in this case is 15. But hopefully you see that the more data that we have, the more cumbersome that method will become. So we do need a different method. So this is where making a probability distribution will help us out. So what is a probability distribution? Well, I'm going to start with a table. And in this table, I'm going to say X is the left, and that simply means my data. So my data, if I just look right here, is 4, 7, and 9. And that's all I have. And in the middle, I'm going to have the frequency. How many times each of these happen? And then finally, the probability, or sometimes we'll just say P of X, the probability that a certain data happens. So let's take a look. So 4, I have 1, 2, 3, 4, 5 of them. Okay, now you can tally right here if you want, but I get a frequency of 5. So let's go on to the 7. So 7, 1, 2, 3, 4 7s. And if I do 9, I have 1, 2, 3, 4, 5, 6 9s. Okay, so now I know I have a total number of data here of 15. That's my total. You might even put that 15 down here as a total box. But I have 15 pieces of data. So to find the probability, that is going to be the frequency divided by our total. So our frequency here would be 5 divided by 15. Now, if we got something repeating, we might choose to, which we do, we might choose to leave that as a fraction just for accuracy purposes. So I'll write here that that's 1/3. Next one would be 4 divided by 15. And I get another repeating thing. I could leave it as 4 over 15 if I wanted, but 0.27 rounded. And then 6 over 15. And I get 0.4. So that one came out nice. When I am done with my probabilities, they should add up to a 1, meaning 100% of the data. And so what we're saying here is if I were to mix all these numbers up and select one randomly, the chance that I select the 4 is 33%, the chance I select the 7 is 27%, and the chance that I select a 9 is 40%. So how does that help us? Well, to find our mean, we would normally add these all up and divide by 15. Instead, to find our mean, what we're going to do is we're going to do 4, that's our first data, times the probability that the 4 happens, plus now 7 times the probability that a 7 happens, then plus 9 times the probability a 9 happens. You might wonder, well, now do I have to divide by the number of data that I have? And the answer is no. I've already done that, haven't I? I've already divided all of these by 15, which is what I do. So basically, what we've done is we've taken 4 times 5, 7 times 4, 9 times 6, and then we divide them all by 15. But the chart just makes it a little bit easier. So let's go ahead and put this in. So 4 times 0.33 plus 7 times 0.27 plus 9 times 0.4. And that gives us our mean of 6.81. All right, now in order to find standard deviation, I need my variance. We're going to do our variance in much the same way. So the way to do variance was to take each data and subtract from it the mean. So I'm going to start that way. 4 minus 6.81. We would square it, but now what we're going to do is multiply by the probability that that happens, that we select a 4 as our data. And now we'll do 7 minus 6.81. We square that, and we'll multiply by the probability that happens, 0.27, plus, I'll put it down here, so here's my plus, 9 minus 6.81 squared times the probability that that happens, 0.4. And I'm not going to have to divide by the number of data that I have because I've already accounted for it in each one of these probabilities. So let's put that all in. And that one's 33% chance, plus the next one is 7 minus 6.81. Square it, and there was a 0.27 chance for a 7, plus 9 minus 6.81. Square that, and there was a 40% chance of a 9. All right, so we get a variance of 4.534. After rounding. That's our variance. Our standard deviation then is the square root of that. So it's the square root of 4.534. So I'll square root that. And I get 2.13. And we're done. So that's basically how we do this. Now, another word in a distribution like this for the mean is expected value, which means if this pattern were to continue over a long period of time, expected value is what I would expect the average to be, which is going to make sense in one of our examples here. So this table shows the number of baskets that Alex makes in a game. How many baskets does Alex expect to make say next season or something like that per game? So this is already tallied up. So we have a 5 here, a 3 here, a 7 here, 4, 10, 8, 6, and 4. So let's see how much data we have right there. So to know how much data I have, I'm going to add all of those up, all of those frequencies up. And I think I got them all. So 47. So there's 47 total data here. So I am going to get weird probabilities, so I'm just going to decide to round to the nearest hundredth. So this would be 5 over 47, 3 out of 47, 7 out of 47. And you don't have to write this. In fact, I'm not even going to write them all. That's how I'm getting them. So 5 divide 47. So 0.11. And the next one, 3 divided by 47, not times. And get 0.06. We just need to make sure that at the very bottom, now I don't know why I said 5 right here. This would have been a 4, right? Or a 7, because there's 7 of them. So 7 divided by 47. 0.15. 4 divided by 47. So it is a little bit of work. 0.09. And the next one, 0.21. And the next one. And we just go through doing this for each one. It's giving us the chance that each of these number of baskets would happen. .13, and lastly, 0.17. Okay, so now to find my mean. which is our expected value, is going to be 10 times 0.11 plus 12 times 0.06 plus ... all the way down to 24 times 0.17. And I'm not going to finish that off. That's how you would do it. You would type all that in, and that gives you the expected value. All right, this one we will finish up because it has a reasonable number of numbers. It says you went gambling, you shouldn't do that, and tracked your winnings and losses. And here's what you got: $10, $5, lost, won. So let's see. The max I won was 20, then 10, then 5. Then I lost 5, lost 10, lost 20. All right, so 20 happens one time. So 1. 10 happens 1, 2, 3, 4 times. 5 happens 1, 2, 3 times. -5 happens once. -10, 1, 2, 3, 4 times. -20, 1 time. So this is X, this is our frequency, and this is our probability of X. So I need a total down here: 1, 5, 8, 9, 14, it looks like 14. So this would be 1 divided by 14, 4 divided by 14, 3 divided by 14, 1 divided by 14, 4 divided by 14, and 1 divided by 14. So let's go ahead and do that. 0.07. It's going to be the same for all of those. 4 divided by 17, or 14. 0.29. And then 3 divided by 14, 0.21. Now, if I add all those up, I should get a 1 right here for 100% of the data. Okay, so now expected value is going to be 20 times 0.07 plus 10 times 0.29 plus all the way down to -20 times 0.07. So it's possible that we just lose a bunch of money. I'm actually going to type all of this in. So bear with me as I get it in there. And hopefully I don't mess up typing it in. Next is -5. So yeah, plus -5. I could just write -5 right there. So I'll do that with this one. And then -20.07. All right, so 0.07s are mean. So what do I expect? Now, was that positive? I expect over the long run to win 70 cents. Kind of not really worth my time. All right, so the variance is going to be 20 minus 0.7 squared times 0.07 plus 10 minus 0.7 squared times 0.29 plus ... I mean, keep on going all the way down till we get -20. Oops. Minus 0.7 squared times 0.07. So I actually will type all of this in so we can see what happens here. So I'm going to actually decide to put in my probability first. It doesn't matter the order that I do it. So the probability that I get a 20 is 7%. So 20 minus 0.7 squared. Now that 0.7 is 70 cents because of the context of the problem. And don't forget to be squaring for your variances. The next one, 10 minus 0.7 squared plus. The next one, hopefully I didn't forget one of these. Oh well, too late now if I did. 21, 5 minus 0.7. It's a long list, so very easy to get lost in it. Now we're on -5. Then we're on -10. And then we are on -20. Again, hopefully I didn't. Oh, see, I skipped the probability of that. So that would throw off this answer. So always be checking, making sure you're typing it in correctly. All right, so that's all of them. 120.5. And then our standard deviation is going to be the square root of that. And that's going to be a number that we're very interested in here shortly. All right, so 10.98. So that means, what does this mean? My winnings deviate from my mean, my whole big mean of 70 cents by about $11.